I'm Anil Kumar, and in this video we'll further investigate vertical transformation of quadratic function. Question is, point A minus 2, 4 is on the parabola y equals to x square, right? So this is a general point A on the parent function y equals to x square. So if you draw a parabola y equals to x square, then you will have, let us say, minus 2, the value will be 4, right? So that is the point which we are considering as point A, right? So this is at minus 2, the value is 4. Point A minus 2, 4 is on the parabola y equals to x square. Equations of transformed parabola are given below. So these 6 equations here are transformation of this particular graph. Write the image of this point on each of the transformed parabola, right? So that is the question for you. For example, the first one is y equals to 2x squared. It really means that the graph of this function has been stretched by a factor of 2. So all y values will be kind of stretched. 0 remains at 0, but all other values will be stretched. So you will get a stretched parabola, which will be kind of like this, opening upwards still, but narrower, right? So that is what. And as it stretches, you observe that this point moves to a different location. So that is the location which you want to know. You can see very clearly that the x value remains same. However, the y value gets multiplied by a, which is 2 for you, right? So the point A, let me call its image as a dash, that point should be what? X value remains same, which is minus 2. The y value gets multiplied by 2. 4 times 2 is 8. So we get that as our answer. This becomes 8 for you. Do you get the idea? Follow this process and answer all these questions, and then look into my suggestions, right? Now part B is, let us start again with the original function, which is in red. And if the transformation is minus 3x squared, then what is the image of A on this graph? That is your question. So in this case, the image is going to be, let me write A prime as minus 3 times y value. However, the x value remains same. So minus 2, and minus 3 times 4 is minus 12. So that is your answer, correct? That is how you should be answering the other 2 questions. Now I'll skip these for you to practice. Let me move on to question number E and F now. Now E and F are slightly different. Here we have 2 kinds of transformations. In the earlier transformations were reflection because of minus, or vertical stretch if it is more than 1, vertical compression if it is less than 1, as in this case. This is also vertical stretch. It is 1.2, 1.5 times, right? Okay. In this case, can you tell me what are the transformations? Here we have 2 transformations. First transformation is stretch by a factor of 5. So we have vertical stretch by a factor of 5. That means y value will get multiplied by 5. And second is minus 1, which is translation, vertical translation by 1 unit down, right? So the second one here is translate. Let me write in a different ink, then I'll show you. So it is translate 1 unit down, right? Now, so in that case, what really happens is, so what we have in this case is kind of like this. Let me sketch this graph roughly for you. So if we have original graph, which is kind of like this, then stretch by a factor of 5 will make it narrower, and minus 1 moves it down to 1 unit. So the graph will be kind of like this. Do you see that? Kind of like this. So the point which we are talking about will actually get stretched and then moved down. So there are 2 operations being performed. However, the x value remains same. So in this case, the point should be a prime will be, x value will still be minus 2, but y value will get multiplied by 5, and then take away 1. Do you understand? So 5 times 4 is 20. 20 take away 1 is 19. So we'll get 19 as the point. Do you understand? Apply this method and get the answer for the second one. In this case, it's kind of tricky. Think like this. What we have here is minus x squared plus 2. That means x value remains same, but the y value gets multiplied by minus 1 and then you have to add 2. So basically in this particular case, the graph moves something like this. This is, let us say, your original graph, right? Now the graph remains in the same shape. However, minus means it gets reflected, and then plus 2 means after reflection it moves 2 units up. So it's kind of like this. Do you see that? That is how it is. So first, when we have a point here, that point is reflected, it will come down and then it will move up by 2 units, right? It's kind of like that, right? So the x value remains same, but what happens to the y value? As far as the y value is concerned, 4 will get multiplied by minus 1. So 4 times minus 1. Then you have to add 2. So if you do that, what do you get? You get minus 4 plus 2 as equals to minus 2, right? So the point really gets reflected and then moves up by 2 units, resulting at minus 2. So in this case, coordinate points will be x value remains same, minus 2. Y value will be minus 2 also, right? So that is how you can get the coordinates for the image of original point on the transformed graph of the function. I hope that makes it absolutely clear. I'm Anil Kumar. You can subscribe to my videos and learn a lot. Thank you and all the best.